So their answer is both of the last two. Both of these will need to go through the loop here, the number of elements in index times. In the case where it's a word that's not in the index, the test will always be false and we'll get to the end of the loop and return none. In the case where the last word is added, we'll still go through the loop the number of elements times, but the very last time we'll find a match and return that element. One of the assumptions in all this analysis is that the time it takes to go through the loop doesn't depend on the actual keyword that's passed in. And that's assuming that this equal comparison takes the same amount of time depending on what the entry and the keyword is, that it doesn't matter what the keyword is, the time to do this comparison is the same. And it turns out that for strings in Python, that's the case, that we can do these string comparisons very quickly because strings are immutable. That means that we don't need to look at all the characters in the string to compare two strings. The double equal for strings can be done in such a way that it doesn't need to look at the whole string. It knows that the strings were created as different strings. That means they're different strings, or if they were created as the same string, they're the same string. So that's the reason why we say that all of the other operations in the loop have constant time, that they don't depend on the size of the inputs at all. These are all very fast operations. What matters in terms of understanding the time is the number of times we go through that index. If you take the follow-on course, which I hope you will, we'll understand how to analyze algorithms in a more formal way. For now, our goal is to develop an intuition. And for that intuition, the important thing to understand is the running time depends on the number of times we go through this loop. Everything that we do inside the loop is constant time. It's not affected by the size of the inputs.